Greetings. Welcome. It's a brand new semester, or at least it was when I recorded this. Actually, when I recorded it was last semester. But that being said, let's just get started. So, we know about the power rule. Remember the power rule? The power rule, the integral, the antiderivative of x to the nth power, some polynomial. Add 1 to the exponent, divide by the new exponent. And that works as long as n is not equal to negative 1. Right, because n was negative 1, so if it was x to the negative 1, we'd end up with x to the 0 over 0. We'd be dividing by 0, right? We'd end up with x to the 0 over 0. X to the 0 is 1, 1 over 0. We don't know. Well, we pretend it's infinity, but we don't know. We can't get an actual thing. So this is bad. This causes problems for us. So much problems that we want to get out the big thing and go, oh my God, what do we do? Okay, so the power rule works as long as n is not equal to negative 1. The question is, what if it is? And that, boys and girls, is what we're going to try to talk about today. But what if it is? But what if it is? So if we have something like the antiderivative, trying to find the indefinite integral of x to the negative 1, we know that that's the same as 1 over x. Well, I'm here to tell you that the antiderivative of 1 over x is the natural log of the absolute value of x plus c. Okay, and the reason we go with the absolute value because the natural log is, remember, it's an exponent. It's exponent base e. And so there's no number that we can raise e to, no number of times that we can multiply e by itself and end up with a negative number. So we always have to have the natural log of the absolute value of whatever it is plus c. Okay, that's just what it is. And so in general, we would say what we're looking for are patterns that say something that show up as u primed over u, du. And if we get that, then we end up with the natural log of u plus c as an antiderivative, as a indefinite integral. Remember, indefinite integral is just a family, and we use anti-differentiation to get there. Okay, so patterns. This is a new pattern that we're going to look for as we work through our integration. Everything in integration is about patterns. Here's one new one that we'll have, u primed over u. That's what we're looking for. Let's look for it now. Okay, well, this is just really 2 over x, so if you want, remember when we have a constant multiplier, we can always pull it out in the front, and this becomes 2 times 1 over x dx. And from the very first slide, remember that, not the first one, but whenever it was, the antiderivative of 1 over x is the natural log of x. So we have 2 natural log, absolute value of x, plus c. Remember what we can do with that 2? We can make it an exponent. Bring it up in the front, natural log. Wow, this thing is getting crazy on me. Plus c. Okay, and I get rid of the absolute value signs there because when I square something, I'm always going to get a positive number. So either one of these answers is reasonably acceptable. If you take that extra piece, go there. I don't know what I just said, but either one's fine. But you just want to, if it's a multiple choice, you want to be able to recognize that if you have this and they have that, it's the same answer. Okay, let's continue. All right. So remember, we're looking for u primed over u. We're looking for the top to be the derivative of the bottom. Okay. Well, the bottom is 4x minus 1. What's its derivative? Its derivative is 4. Do we have 4 on the top? No, but could we make 4 on the top? Sure, just like that. Okay, and that's sort of the equivalent of putting a 4 in. If we put a 4 in, we must take a 4 out. Okay, when we've done this, we've set it up so it's in the form of u primed over u. We know what the antiderivative of u primed over u is. It's the natural log of u, and in this case, u is 4x minus 1 plus c. Okay. If you want to bring that into the fourth root, I don't know that I would. I would leave it that way. It's probably easier to calculate. Instead of getting into the fourth root of a natural log, we can just do the natural log of some number and then take the fourth of it if we were actually to evaluate it at a particular point, or to have to do a definite interval. Okay, looking for u primed over u. That's our mission. Find u primed over u. Sometimes it's easy to see, sometimes maybe not so much. So u might be x cubed plus x. So let's see what du is. Du, well, the derivative of this looks like it's 3x squared plus 1 dx. So we could easily make this into du over u, or u primed over u, whichever way you want to go about it. So the antiderivative of u primed over u is the natural log of u plus c. Okay, that's what we're looking for. Pattern. U primed over U. Let's continue. Okay, ooh, this could be fun. U primed over U. So, well, if U is x cubed, U prime 3x squared, but I get 5x squared, and then I get 2x over here. Hoping you were thinking it before I even said it, before I drew in. That this, with the magic pen, this is an STD, right? So we know how to deal with STDs. We break them apart. We break them down. We fight them. So this becomes the antiderivative of, oops, there it goes, 5 over x, slow it down if you need that, plus 2 over x squared. Okay, and we can work with either of those. Let's just do the little bit of simplification step. We'll leave that one as 5 over x. We'll make this one 2x to the negative 2 dx, that's 2. Okay. This we can take an antiderivative of with natural logs. This we can take an antiderivative of with our power rule. And so, let's do it. So the first part becomes 5 natural log absolute value of x. The second part becomes 2x to the negative 1 divided by negative 1. Remember, add 1 to the exponent divided by the new exponent. So when all is said and done, this becomes 5 natural log absolute value of x minus 1 over, oh, how about 2 over x? That would be better. Plus c. Okay? So, STDs, they're still around. Trying, but we want to get rid of them. Continuing on. All right, secant tan over secant. Well, let's take a look. If the bottom is secant, what's the derivative of secant? Secant tan. Okay, so we got a u primed over u. So it turns out that this is going to be the natural log of the secant of x plus c. Cool. Okay, u primed over u. U primed over u, the derivative over the other part. Just for good order, continuing, moving onward. Oh, hey, let's just do the antiderivative of tangent of x. So tangent, if you remember, we can rewrite as sine x over cosine of x dx, right? And we try to find a pattern of u primed over u. U is cosine of x. Du is the derivative of cosine, negative sine of x dx. We almost have it, don't we? Oh, we do now if we do this and this. So this fits my pattern u primed over u, so my answer is the negative natural log of the cosine of x plus c. Okay? Alright, I've been messing with you because those last two problems were the exact same problem, weren't they? Okay? So on the one hand, you know, if I do secant of x like so, that's the same thing, right? That's tangent of x. So here's what the crazy part might be. On the one hand, we got the natural log of the secant of x plus c. On the other side, we ended up with the negative natural log of the cosine of x plus c. Are they the same thing? Well, let's think. How are secant and cosine related? Well, secant is one of those reciprocal trig functions. It's 1 over the cosine. And sometimes we might write 1 over the cosine, cosine x, to the negative 1. And what could we do with that negative exponent? Well, we could bring it out front, and we end up with negative natural log cosine of x. And that's what we had over here. Okay? Plus. All right, so they're the same thing. I think that's my point. Here's another point. Now, with all this stuff, we're able to have antiderivatives of all of our friendly trig functions. Okay, the antiderivative of sine we've had for a while, negative cosine. The antiderivative of cosine, positive sine. Now we just got today the antiderivative of tangent. It's the negative natural log of the cosine. The antiderivative of cotangent is the natural log of the sine of u plus c. And then secant is this, cosecant is that. Okay, and you notice there's some patterns. Secant and cosecant, sorry, same thing. One's negative, one's positive. Tangent, cotangent, same story. Okay, these are some things we're going to want to eventually need to have in our brains. For right now, they're on our little card. Okay, so there's an extra little formula, and so it's another pattern that we can get to. If we see that something that looks like the tangent of something, and we can work it out, we get the negative natural log. Okay, cool. Oh, find the area bounded by x squared plus 4 over x. X equals 1, x equals 4, y equals 0. Okay? So basically, we've got some sort of curve. We're wondering what's going on with that curve, and I don't have no real recollection of what it looks like. Maybe it's that. Something like that. I don't even know. And there's 1, and there's 4. Maybe I do know. I don't know. And there's y equals 0. So we're trying to find the area, like about there. Okay? So finding the area under the curve sounds like a definite integral to me. And the definite integral between 1 and 4 of x squared plus 4 over x dx. Yeah, so y equals 0 just means we're talking about above the x-axis. How are we going to handle this? Well, we're going to simplify it because we recognized almost immediately that that was an STD. So it's x plus 4 over x, right? We now have to differentiate x. And this is just 1 for 4. So x squared over 2. X squared over 2. We know how to anti-differentiate 4 over x. Why, it's 4 natural log of x. And we're not doing a plus c because it's a definite integral for 1. Okay? So now we get to evaluate. We've got 4 squared over 2 plus 4 natural log 4. Okay, that's the first part. Then we're going to subtract away 1 squared over 2 plus 4 times the natural log of 1. Okay? Use parentheses, I guess, but just crazy that way. All right, so 4 squared. 4 squared is 16. 16 divided by 2 is 8. Plus 4 natural log of 4. 1 squared is 1. 1 divided by 2 is a half. We're going to subtract that half. The natural log of 1 is 0. 4 times 0 is still 0. And so I end up with 16 halves. Right? That's 8 minus a half, so probably 15 over 2 plus 4 natural log 4. That's a delightful answer. We can leave it like that. If we really needed a decimal, we could get that decimal, but we don't need to get involved with decimals. Perhaps we don't have our calculator handy. All right, so finding the area, finding the definite integral. Remember, definite integral gives us a number. In this case, it's the number that is associated with the area under this curve, and whatever curve it is, it's just a picture. So there's that. There's that. That's the homework assignment that's coming up. Two options for you. And so, remember, U primed over U. It's the pattern we're looking for. Okay, we don't want to make everything fit that pattern, but we want to do our best to make it happen. 12 minutes, 59 seconds. Delightful. Thanks for joining us on this next leg of the journey. And see you tomorrow. If you have questions, you let me know. As always, I hope you learned something. See ya.